What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA 220-1001 exam. So let's get into it. In this video, you will learn about common networking hardware devices such as routers, switches, access points, cloud-based network controllers, firewalls, network interface cards, repeaters, hubs, cable, DSL modems, bridges, patch panels, power over Ethernet, and Ethernet over power. A router is a networking device that forwards data packets between computer networks. Routers perform the traffic directing functions of the internet. Data sent through the internet, such as a web page or email, is in the form of data packets. A packet is typically forwarded from one router to another router through the networks that constitute an inter-network or the internet until it reaches its destination node. Devices that are connected to a LAN via a router connected to a cable modem or DSL modem allows for these devices to share a broadband connection to the internet. A router has at least two network connections that use RJ45 cables. The port labeled WAN or wide area network connects to the router to a modem. The port labeled LAN or local area network connects to the router to a switch. If the router has a built-in switch, it has multiple LAN ports that are numbered starting at the number 1. Most routers today are wireless routers that use the 802.11 Wi-Fi standards to where they combine a router, a switch, and an access point. A router has two IP addresses because it has two network connections. One network connection uses a private IP address and is used to attach to LANs or ports numbered 1 through 4 or higher. The other network connection is the one used to connect to the internet via a modem, and this is your public IP address. And here is a picture of a typical Cisco networking router. And here is a picture of a typical SOHO or small office home office router. You probably have one of these sitting in your house right now. A switch is a high-speed device that receives incoming data packets and redirects them to their destination on a local area network. Essentially, switches are the traffic cops of a simple local area network. A switch enables direct connections between any two computers or devices on a network. A switch makes a direct connection between the sending and receiving devices by identifying the media access control addresses or the MAC addresses of each device. Switches are available with as few as 4 or 5 RJ45 ports or with dozens of ports. Switches can be connected to each other to where they are stacked or daisy chained so that a small network can grow without needing to replace existing switches. Most switches support at least fast Ethernet, which is 100 megabits per second signaling, with gigabit Ethernet or 1,000 megabits per second becoming common in home and small office networking. 10 gigabit Ethernet switches are now used in enterprise networks. Low-cost switches used in SOHO networks cannot be configured to perform complex switching functions and are considered unmanaged. A managed switch can organize its switch ports into several logical networks, also known as virtual LANs or VLANs, that cannot interfere with each other, which enables different companies or departments to have independent networks in the same physical location to keep their traffic separated. Managed switches also support SNMP for diagnostics and performance measurements. To enable a switch network to connect to the internet, you would have to connect a switch to a router. Many networks made for home or small offices include a multi-port switch and a wireless access point. A wireless access point, also known as a WAP or an AP, is a networking hardware device that allows other Wi-Fi devices to connect to a wired network based on the IEEE 802.11 standards. The wireless access point usually connects to a router via a wired network as a standalone device, but it can also be an integral component of the router itself. Wireless access points act as central connecting points for computers, equipped with wireless network adapters by identifying each computer by its MAC address. To connect the wireless network to a wired network, you would connect the RJ45 port on the wireless access point to a switch on a wired network. If the wired network is connected to a router with internet access, the wireless network will also have internet access. And this is a typical picture of a wireless access point. If you walk around some office buildings, you might see these things sitting on the ceiling. These are the things that help facilitate your device to get access to the internet. Cloud-based network controller. So a cloud-based controller is a tool that transfers data from on-premise to cloud storage. For achieving that purpose, the cloud-based controllers typically use hard disk drives, solid-state drives, or a combination of both to store the data on-premise. Cloud-based networking is considered the next generation of computer networks. Cloud-based controllers allow for administrators to manage local area networks and branch offices located anywhere on the internet from a centralized location. A firewall is a network security system that monitors and controls incoming and outgoing network traffic based on predetermined security rules. A firewall typically establishes a barrier between a trusted internal network and untrusted external networks, such as the internet. Firewalls can be either software or hardware. Firewalls are frequently incorporated into wireless routers, Microsoft Windows and Mac operating systems. Software firewalls are also known as host firewalls. Now, firewalls, they work like this. A computer from outside the network attempts to gain access to a server on the network that has a firewall. The firewall blocks the incoming traffic from the computer because no computer from inside the network has sent a request to the outside computer. A computer on the network sends a request to a remote server hosting a website. The remote server responds back to the computer on the network. Because the remote server is responding to a request from the network, the firewall permits the incoming traffic. So you could think of a firewall in the manner of that of a bouncer at a club who controls who gets to go into the club and ultimately who gets kicked out of the club. Network interface card. So a network interface card, also known as a NIC card, is a computer hardware component that connects to a local area network. A NIC originally was a circuit board card mounted to the motherboard, but now NICs are built-in interfaces that connect to a network using cables via an RJ45 connector, or they can connect wirelessly. The NIC is designed to take communication off the physical cable or wireless signal from the air and present it to the computer for processing. The NIC is both a physical layer and data link layer, as it provides physical access to a networking medium and provides a low-level addressing system through the use of MAC addresses that identifies devices to other hosts on the network. NICs have evolved to also provide wireless and virtual access to networks. And that is an image of a standard NIC card that you will find on a desktop computer. A repeater or an extender is an electronic device that receives a signal and retransmits it. Repeaters are used to extend transmissions so that the signal can cover longer distances or be received on the other side of an obstruction. Wireless signals can be blocked by a variety of objects such as bricks, steel, and concrete walls. Distance can also weaken signals as well. Wireless repeaters can look similar to wireless routers, and some even include a switch component, but instead of connecting to a cable or DSL modem, a repeater connects wirelessly to a wireless router. A hub is a network hardware device for connecting multiple Ethernet devices together and making them act as a single network segment. Hubs were used to connect computers together and to boost the communication signal between computers. It has multiple input-output ports in which a signal introduced at the input of any port appears at the output of every port except the original incoming port. A network hub is considered an unsophisticated device in comparison to a switch. A hub cannot examine or manage any of the traffic that comes through it. A hub has no memory to store data. It can only handle one transmission at a time, and it splits the bandwidth of a connection amongst all computers connected to it. And it broadcasts data to all computers connected to it. When it comes to the splitting of bandwidth, a 5-port Ethernet hub, it will divide the 100 megabits per second speed of the fast Ethernet amongst 5 different ports, therefore only providing 20 megabits per second of bandwidth to each port for fast Ethernet. With that being said, hubs have become extremely rare in networks. And here is a picture of a hub. And basically what you're looking at here, you see the signal coming in through one port right here. And as it enters the hub, that signal is broadcasted to every other port and device that is connected to that port. That is essentially what a hub does, ladies and gentlemen. Modem. So a modem or a modulator, demodulator, or modulate, demodulate is a hardware device that converts data into a format suitable for a transmission medium. So it can be transmitted from one computer to another, historically along telephone wires. A modem modulates one or more carrier wave signals to encode digital information for transmission and demodulates signals to decode the transmitted information. The goal is to produce a signal that can be transmitted easily and decoded reliably to reproduce the original digital data. Modems connect a LAN to an ISP. Dial-up modems allow computers to gain access to the internet by converting the computer's digital signals to analog signals used by a LAN-based phone line. The issue with dial-up modems is that they are very slow devices and are typically used if no other internet option is available. The most common modems in use today are that of cable and DSL modems. And here is a picture of a typical cable modem that you would find in your house if you have cable internet access. A wireless bridge connects 2 wired networks together over Wi-Fi. The wireless bridge acts as a client, logging into the primary router and getting an internet connection, which it then passes on to devices that are connected to its local area network. A patch panel is a device or unit featuring a number of jacks, usually of the same or similar type, for the use of connecting and routing circuits, for monitoring, interconnecting, and testing circuits in a convenient, flexible manner. Patch panels are typically built into a wiring closet or added to equipment racks. Patch panels are primarily designed as a termination point for twisted pair and fiber cables that are used in networks. Twisted pair cabling is a type of wiring in which 2 conductors of a single circuit are twisted together for the purposes of improving electromagnetic compatibility. Compared to a single conductor or an untwisted balanced pair, a twisted pair reduces electromagnetic radiation from the pair and crosstalk between neighboring pairs and improves rejection of external electromagnetic interference. Twisted pair cables must be untwisted before being punched into the appropriate connection on the back of a patch panel. Twisted pair cables are color-coded to allow for the proper termination of the cables. The most common standards for color coding are known as T568 Alpha or straight through, or T568 Bravo or for crossover. The front of the patch panel uses RJ45 connectors for short standard network cables. And here's a picture of the RJ45 pinout for these cables, showing you the color codes for the T568 Alpha and the T568 Bravo cables. You will learn about this as we proceed on with this class, so don't be too concerned about it right now for this particular video. Ethernet over power line. So power line networking is a technology that sits between wired and wireless. Ethernet over power lines uses the existing electrical wiring in a home or office to transmit network data. This can be a practical solution when there is a need to extend a wired or wireless internet connection. Ethernet over power lines provides power line adapters that are sold in pairs. One unit for the AC wall socket, which is connected to the router via a switch, and the other adapter plugs into an AC wall socket in a room that needs network access. And here's a picture of how a network power line adapter would work. So as you can see at the bottom right here, you have a power line adapter that is connected to a router. That power line adapter is plugged into the wall where it is sending the signal through the electrical wiring in this house up to the 3rd floor, which is then going to this other adapter, which is kicking out Wi-Fi, which will then send the signal to this smart TV, this laptop, or any other Wi-Fi driven device. And the reason is because this picture is making the assumption that the Wi-Fi signal from this router is being blocked or is too weak to reach all these devices on the 3rd floor. So this could be an economic solution to dealing with those issues if you are experiencing them in your own home right now. And finally, power over Ethernet. So power over Ethernet describes any of several standard or ad hoc systems or switches that pass electric power along with data on twisted pair Ethernet cabling. This allows a single cable to provide both data connection and electric power to devices such as wireless access points, IP cameras, routers, VoIP phones, and other Ethernet devices. The power over Ethernet switch can send up to 25.5 watts of power on Cat5 or greater grades of unused twisted pair wires using pins 4 and 5 or 7 and 8, or by using all 4 wire pairs, which allows for it to be used with gigabit Ethernet. Another type of power over Ethernet device, which is known as a power over Ethernet injector, is installed between a standard Ethernet switch and a power over Ethernet device to provide power only. All right, so let's go ahead and get into some check on learning, shall we? So the first question is, which of the following technologies can support Ethernet communication using a building's power infrastructure? Would it be Ethernet over power? Would it be power NIC? Would it be power-based network controllers? Or would it be power over Ethernet? So which of the following technologies can support Ethernet communication using a building's power infrastructure? The correct answer is Ethernet over power. So remember, Ethernet over power, which is also called power line communication. It allows Ethernet signals to be sent over standard electrical power wiring in a building. This is helpful for situations where both Wi-Fi and running new Ethernet cabling is not supported. Usually this is done by using adapters that plug into a wall power outlet and they have RJ45 ports on them. Next question. What type of network switch supports plug-and-play style usage and does not support custom configurations? Would it be a POP switch? Would it be a level 5 switch? Would it be a managed switch? Or would it be an unmanaged switch? So which type of switch supports plug-and-play and doesn't have custom configurations? The correct answer is an unmanaged switch. So an unmanaged switch does not support, or it has very limited configuration options and is meant to work for most networks right out of the box. Managed switches, they require configuration to properly function, but they offer more features and functionality. And the final question is, you've just installed a wireless access point upstairs in your new home. However, when you go down to the basement, you lose your signal and can no longer surf the internet. What type of equipment could you buy if you did not want to purchase another access point, but you wanted to keep wireless connectivity? Would it be a repeater? Would it be a switch? Would it be a router? Or would it be a hub? You got your Wi-Fi device set up upstairs. You're in the basement. You can't get any internet access. What device are you going to purchase, ladies and gentlemen, from this list? The correct answer is a repeater. A repeater can resend the wireless signal into an area that is not covered by the original access point. This would be a good alternative option to buying another access point and can easily repeat the signal onto another floor of a home. All right. So in summary, we have talked about common networking hardware devices such as routers, switches, access points, cloud-based network controllers, firewalls, NICs, repeaters, hubs, cable DSL modems, bridges, patch panels, Ethernet over power, and power over Ethernet. Now, if If you feel like you have gotten something valuable from this information, please go ahead and hit the like, share, drop a comment, and also subscribe to this channel. And most importantly, go visit my website, technologyg.com, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA 220-1001 exam. And until next video, ladies and gentlemen, peace.